Where are we? Well, we're headed into a chapter 12, where you're going to have an opportunity to take a look at mid-latitude cyclones. And mid-latitude cyclones are so important and so key to understanding weather conditions, particularly in regions like New Jersey, where it's such a common phenomena to experience the passage of or the weather associated with a mid-latitude cyclone. Now, to kind of take this in perspective, we have 4 different scales of phenomena on this planet. We have global winds, and for those who are following what's happening, and you should be, with the disaster in Japan and with the radiation release from the nuclear power plant in Japan, you know the people in California are wrongly worried about the radiation reaching the West Coast. It will, and it has, but it's in such small concentrations that that's not an issue. The important thing to understand is that radiation traveled all the way across the Pacific in a matter of days because of a belt of global winds called the westerlies. The westerlies are a mid-latitude wind belt, and you should, to refresh yourself, take a look at global winds. They're addressed in the text. You can look them up online. You'll see that there are 3 major belts: the polar easterlies, the westerlies, and the northeast trade winds. So that's global winds. That's winds that will blow across the entire planet. That explains why, if you fly to Los Angeles, it takes longer to get to LA than it does from LA to get back to New York. Okay, Synoptic Scale. That's been my focus in the Weather Roman numeral 2 posting that you had in your Unit 2 folder. Now, Synoptic Scale is large-scale weather systems, air masses, and cyclones. I'll rephrase: high-pressure systems and low-pressure systems. So you've been focused a little bit on high-pressure systems, and yesterday certainly there was tropical air over New Jersey, and now you're moving back towards a modified polar air mass. Does that mean that polar and Arctic air can no longer affect New Jersey? No. Going into late March and early April, and even well through April and into May, Arctic air can move across New Jersey, and snow has fallen as close to New Jersey as the middle of May up in central New York State. And certainly New Jersey can get snow well into April. So it's not necessarily over, as much as yesterday made it feel like it was over. Well, anyway, so we have Synoptic Scale, and that's where we're going to continue with that theme. There are smaller scale phenomena, mesoscale and microscale, and we'll get there before we have our next exam, and that'll be coming up relatively soon. So let me kind of get you focused and oriented as to what I want you looking at. I'd suggest you begin by reading Chapter 12, which talks about mid-latitude cyclones and fronts. Now, there's some supporting materials. You'll find in the Unit 2 folder there is a cyclogenesis, 2 cyclogenesis visuals. I would suggest that as you begin reading Chapter 12 and you begin to hit on the idea of a cyclone and cyclogenesis, that you go to those visuals. I would also suggest that you avail yourself of the 3 websites that I'm about to show you. You can get the website addresses by simply taking a look at my address bar up here, the URL for the website. This is a USA Today page, and USA Today has an excellent tutorial on cyclones, low pressure systems, how they affect weather, extratropical storms, if you will, and you have hot links here where you can take a look at additional details. So if I click, for example, on warm front, the page that loads provides a visual, somewhat interactive, illustrating what happens and what's going on with a warm front, and you'll learn a bit more by reading the material below it and reading the captions off to the right. So that's USA Today. Additionally, ClassZone.com, an excellent college-level website, has a couple of visuals, one on cold fronts, and you again can garner a tremendous amount of information from this, and one on warm fronts. So I would encourage you, as you're reading into Chapter 12, this will help to bring the material alive. Finally, this is a relatively old website, WW2010. It's a University of Illinois page. Again, you can get the URL from up top. And what I want you looking at here, and you can feel free to go back to the root page, which is right here, where you'll see a number of different phenomena. But what I particularly want you looking at is the changes that occur with a frontal passage, much like the front that you saw pass through between March 18 and March 19, 2011, just in case you're watching this in a future date. The temperatures apparently ran from the upper 70s on the 18th, and on the 19th, I think you'll probably stay in the 50s. So, what do you need to know about Chapter 12? Well, here's what I want you to do. I want you to read the overview beginning on page 313 on mid-latitude cyclones. Make sure on pages 314 to 316 you're reading about polar front theory, and that's where you probably want to have a look at cyclogenesis visuals that I've put into the Unit 2 folder. And be sure you read the discussion where mid-latitude cyclones form, particularly as it relates to nor'easters. I mean, that was this winter. This was the winter of nor'easters, and who knows, maybe they're not over. But certainly, there will be more winters to come for you and me, and when those winters come, you will see more nor'easters if you're still living in the northeastern United States or the mid-Atlantic. Both receive nor'easters. So be sure you know the story behind that. That's, I believe, addressed on page 317. You can feel free to skip the discussion, the section on vertical structure, on deep dynamic lows, but again, be sure to read about nor'easters within that discussion. Read pages 320 and 321 for a general understanding. This is where the author talks about convergence and divergence. It's interesting reading. It's a little in-depth, but again, just a general understanding. I don't need you to know details. Same thing with upper level waves. It'll help you to understand some of the nuances of weather. Now, on page 322, again in chapter 12, make sure that you're reading about the ingredients for developing a mid-latitude cyclone, because every time it gets cold in New Jersey, you don't get a snowstorm. So understand what you need in place in order for that to happen. The role of the jet stream on page 323, very, very important. But then feel free to skip the section on jet streaks unless you find it real interesting. But then pick up with the conveyor belt model. Make sure you understand that. It'll help with your understanding of global winds. Read the case study on the superstorm of March 1993. It's getting scary. Some of you may have been very young children at that time, but I remember that extremely well. And that storm was an amazing, amazing event. It occurred just within days of when you're actually watching this. And it affected millions of people, all from the southeastern U.S. all the way up through Maine and into Canada. You can feel free to stop at page 329, mid-page, skip the vorticity discussion. You don't necessarily need to get into that depth, but make sure you hit the summary on page 335. Then, at the end of the chapter, I'd like you to look at page 336, numbers 2, 10, 14 through 16. Once again, 2, 10, and 14, 15, and 16. Also the question for thought number 1.